Imagine that you're walking 3 kilometers to the east one day, and the next day you're walking 2 kilometers to the west. What is the resultant displacement? It's basically asking us to add these two vectors. So if they are in one dimension, it's really easy. There are two ways to do it. The first one is graphical method. In graphical method, all you're doing is place the vectors head to tail. So first the first vector, you place the first vector 3 kilometers, and then place the second vector head to tail. So start from the head and then place the second vector to the tail, something like this. This is 2 kilometers. Okay, and the resultant vector is the vector starting, it's a new vector which is starting from the tail of the first vector, so that's from here to the head of the other vector. So this is the resultant. So of course you can see that this is 3 kilometers. So of course you can see that the length is 3 minus 2, 1 kilometer. And because this was east, so this is to the east. So the direction is showing us the direction of the vector, and the length is giving us the magnitude of the resultant vector. So the net displacement is 1 kilometer to the east. So this is the simple way to add two vectors in one dimension, place them head to tail, and the resultant is the vector starting from the tail of the first vector to the head of the second vector. So we can also add them algebraically, because it's a one-dimensional. It's really easy to add them algebraically. So what you can do is, we already learned about the sign convention. So use the sign convention. So what I'm going to do is, first I'm going to write down my sign convention in here. So the east is taken as positive. That's my choice. You can choose the other way, but stick with that if you choose the other way. So west is taken as negative. So the west is taken as negative. 3 kilometers to the east is then, because that's a positive direction, that's a plus 3 kilometers. And 2 kilometers to the west is minus 2 kilometers. So now it's all about just adding these two numbers together. It's a plus 3 plus minus 2. So which is plus 3 minus 2 is plus 1 kilometer. So which is simply saying the magnitude of the vector is 1 kilometer, and this plus is giving us the direction. The plus is standing for east, so this is telling us 1 kilometer to the east. This is how we add one-dimensional vectors, either by graphical method or by algebraic method. Let's now learn how to add vectors when they are in two dimension. Consider two vectors, 3 meters to the east, 2 meters to the south. How can we add these two vectors? We already learned how to add one-dimensional vectors, and that was really simple. And now we're going to learn how to add these two vectors when they are in two dimension. First of all, we can only add vectors in two dimension if they are in the same plane. These two vectors are in the same plane, so we can add them. And there are two ways to add them. So one is graphical way and another one is geometrical way. In graphical method, this first method is head to tail method. In head to tail method, what we're going to do is place the vectors head to tail, as you can see in here. Okay, so head to tail, so you can move the vector, one of the vector, it doesn't matter which one you move, but you should place them head to tail. I'm going to move this vector, the 2 meter one, and then place it in here. So that's here. So while we move, one thing we should be very careful is not to change the length. So you should use the ruler and don't change the direction as well. So you should move it parallel to the original vector and place it at this way with the tail matching with the head of the first one. So now it's exactly 2 meters and then it's pointing to the south. Okay, now the resultant or sum of these two vectors is the vector. It's really simple. Look at this one. So vector starting from the tail of the first one and then ending at the tip, the head of the last vector. Okay, or the second vector, because we have only two vectors, and if you have more than two vectors, it's a last vector. So place them all head to tail, and then the vector starting from the tail of the first vector and ending at the head of the last vector is the resultant. Okay, so how can we find this length then? So the first way is really simple. Use a ruler because this is 3 meter. So you need to scale it properly. So for example, if it's a 3 meter, scale it to be like 1 centimeter is 1 meter, and then 1 centimeter is here 1 meter as well. So and then if you're measuring 3.6 centimeter, so that's when you use the scaling, this will be 3.6 meters. So you can measure it exactly to be 3.6 meter if you made it appropriate, if you drawn it to the appropriate scale. And to measure this angle, you can use the protractor, and you can measure this angle to be 34 degree. And then once you've done that, so to mention about this angle, you can say this is 34 degree, and this angle is measured to the south because this is the south direction and the reference is east, or you can say 34 degree south of east. Or in another way, you can also mention this direction in terms of this angle. So if this is 34 degree, you can find this is 90 minus 34 degree, so which is 56 degree. And then you can say the same direction, you can say it's a 56 degree, but this is the reference line south, and that's measured towards east, so it's the east and of south. Or you can say it's a 56 degree east of south. Okay, so even if these vectors are any direction, you can use the method. So for example, if you have one vector like that and then another vector like that, any angle, so not only for perpendicular vectors but for any vectors in 2 dimension in the same plane, but any angle, so you can use this method, acute or obtuse, but all the time the resultant is the vector which is starting from the tail and ending at the tip when you place them tip to tail. And you can measure the length using the ruler, and you can measure the angle using the protractor. Okay, so that's the one of the graphical method. So the second method is parallelogram method. In parallelogram method, it's quite similar to this one. So instead of making it head to tail, you place them with the tails matching. So you place this first vector here and then second vector with the tail matching. So again, you have to move these vectors to make it make the tails together. So it's a 3 meter to the east, and this is 2 meter to the south. And then you have to complete the parallelogram. So that means you need to draw a parallel line of this one, so the 3 meter one in here, use the dotted lines, and then a parallel line for this one, and that's also a dotted line. And once you've done that, the resultant is the vector starting from the tails matching place, intersection of the tails, to the intersection of this dotted line. So that's the resultant vector. So even if you're measuring the length of this vector, it will be exactly the same as 3.6 meter, and then you will get the angle same as 34 degree. And even if the vectors are at random angle, not at right angle, so again you can use the same method. So for example, if you have two vectors of this way, again what you have to do is, after placing them with the tails matching, you need to complete this parallelogram, make this exactly the same one, parallel, same length and same direction. You don't have to put the arrowhead, and then draw this as well, and then the resultant is the vector starting from here and ending it in here. Okay, so this is the parallelogram method. So we've learned two graphical methods. One is head to tail and one is parallelogram method. So you can opt whichever you like, but both should give you the same answer. So this graphical method is only approximate because you're heavily relying on the measuring using the ruler and then protractor. So there could be errors, as the scaling is one thing you should do as accurate as you can. So that's why we use a geometrical method. Okay. So the next one is, so in geometrical method, you can add them quite easily without actually measuring using the ruler and a protractor. Okay, so you don't have to use the ruler and a protractor. Instead, you will be calculating, you'll be finding this length and angle mathematically. But the only problem with that is you can only find the resultant of perpendicular vectors. So the starting point of geometrical method is quite similar to the head to tail method. You place them head to tail, and once you place them head to tail, so this is a 3 meter and then this is a 2 meter, and then we can say, okay, this vector, the resultant is the vector which is starting from the tail of the first one to the tip of the second one. Now, instead of using ruler and protractor, you will be using Pythagoras theorem to find this length and this angle. The Pythagoras theorem says if this is A and this is B, the length, this is the hypotenuse of the right angle triangle, and that's A square plus B square. Okay, using this one, you can find this length of this one, which is square root of 3 square plus 2 square, and that's exactly 3.6 meter as you measured using the ruler. Okay, and then you need to find this angle. For that, you can use any of the trigonometric ratio. So there are 3 different ratios which you can consider using, which is sine theta is opposite side on hypotenuse, and cos theta is adjacent side on hypotenuse, and tan theta is opposite side on adjacent side. Okay, let's use the last one, which is quite easy here. Doesn't matter which one you really use. And opposite side is 2 meter and adjacent side is 3 meter to this angle. So that's 2 on 3. And then to get the theta, you finding tan inverse of 2 on 3, which you will get as 34 degree. Okay, when you check that in when you put that into a calculator. And once I get 34 degree, again the angle should be mentioned the same way as we did before. It is 34 degree towards south from east, or you can say this is 56 degree east of south. Okay. Summary: we've learned a graphical method as well as a geometrical method, but the geometrical method works only if the vectors are perpendicular to one another.